Good morning or good afternoon. Today we're going to talk about triangle inequality theorems. And there's actually a few triangle inequality theorems. Just remember that an inequality is whenever we have one of these symbols. So it's less than, greater than, less than or equal to, greater than or equal to. And we'll talk more about those symbols in a little bit. So the first triangle inequality theorem tells us if it's possible to even construct a triangle. So it says, is it possible to construct a triangle with the given side lengths? If not, explain why not. So not all, if you had sticks, not all sticks would make a triangle. For example, let's say I had a really long stick and then two short ones. Well, no matter how hard I try, that's never going to make a triangle. And maybe I move this one over, well, it still doesn't make a triangle because I have all of this excess, all of this overlap. But let's say that I could actually stretch it and make it longer. Well, now I have a triangle, but there's rules. There's things that have to be done in order for me to create or construct a triangle. And that first triangle inequality is that your two shorter legs have to be greater than the longest leg. And our formula is that A plus B has to be greater than C, where A and B are our short sides and C is the long one. So, is it possible to construct a triangle with the given side lengths? Well, ask yourself, what are your two shorter sides, 6, 10, and 15? And our two shorter sides would be 6 and 10. So add them. 6 plus 10 is 16. And then ask yourself, is 16 greater than 15? Yes. So then yes, it will make a triangle. And that's all that you have to do to check if it makes a triangle. So let's take a look at the next one. If we have 5, 13, and 8, ask yourself, what are your two shorter sides? So what are the two smaller numbers? That would be 5 and 8. Well, 5 plus 8 makes 13. Is 13 greater than 13? Well, 13 is not greater than 13. They're equal, which means no, it doesn't make a triangle. So for this one, we're pretty much just adding our two small numbers and checking to see, does it make a triangle? Now, back in this, it said if not, explain why not. And I have my explanation. My explanation is literally my work. You should have some work for these where you've added the two shorter numbers and you're checking, and I know that some of you can do it mentally, but that is your explanation for yes or no. Yes, because that statement is true. No, because that statement is false. So that's all that you need here. So see if you can do this next one on your own. And hopefully you will be able to get no, because 11 plus 16 is 27. And is 27 greater than 32? No, so it does not make a triangle. Now if I look at this last one, I have 4, 8, 8. So I have 8 in there twice. So if it made a triangle, it would be isosceles because I say 8 twice. In this case, it doesn't matter. 4 is the shortest length. I'm just going to pick one of the other 8s. 4 plus 8 is 12. Well, is 12 greater than 8? Yes. So this would make a triangle. And that's one of our first triangle inequality theorems. Now, sometimes they give you two sticks or they give you two sides and they want to know the possible lengths for your third side. So if we think about it, I'm going to draw two pictures. Let's say you have two sticks like that, so then I could just connect those. That makes a triangle. Or maybe they give you two sticks like this. And now I need a much larger piece to connect them and make a triangle. There's a range of lengths. There's possible lengths for that third side. And hopefully you heard me say the word range, because sometimes instead of possible lengths, you will see the word range in a problem. So all that I'm doing for the range is I just need to figure out what numbers is it between. What are all my possible lengths? And our formula for that, so our second formula, is you're going to subtract, which means that your possible lengths, or our x value, is going to be between the values after we subtract and we add. And we'll write it just like this. Excuse me. So I'm going to subtract and then I'm going to add them, and it should always be positive. So if you type it in and you get it wrong, or like a negative number, something went wrong, or just change it to a positive, because side lengths of triangles have to be positive numbers. So if I have this right here and I do 12 minus 6, well, 12 minus 6 would be 6 inches. If I add 12 plus 6 would be 18 inches. And so my possible side, x would have to be greater than 6, but less than 18. Be very careful of your symbols in that direction. And that's all of your possible side lengths. Now, this isn't less than or equal to, it's just less than, which means that it falls between those values. Which means that while 6 would not work, 7 would work, 8 would work, 9 would work, 10 would work, 11, 12, 13, 14, 15, 16, 17, but not 18 because it needs to be between those numbers. Because if I had 6 itself, well, 6 and 6 would be 12. 12 isn't greater than 12. So it has to be the numbers between those values. So let's take a look at the next one. If I asked you for the possible lengths, go ahead and subtract. So 8 minus 3 would be 5 feet. Add 3 plus 8 would be 11 feet. So your possible lengths would fall between 5 and 11. So in this case, 6 would work, 5.2 would work. Anything that's greater than 5 but smaller than 11 would work. I'm going to see if you can do this next one on your own. Take a minute. Whenever you subtract, you should get 5 centimeters is less than x, which is less than 29 centimeters. Now, let's say you did 12 minus 17, and so you got a negative 5. Well, you just flipped them. It should be 17 minus 12. It's always the bigger number first whenever I'm subtracting them. If you get a negative number, you just changed up the order a little bit. It should be positive. And for our last one, if I subtract them, then I get 6. And if I add, I get 20. Meaning that it could be any value between 6 and 20, but not actually 6 or 20. Those wouldn't work. So those are our main 2 triangle inequalities. So let's look at a few more examples. The figure shows the approximate distances between cities in California. So we have San Francisco, Oakland, and San Jose. If you've ever been to any of those places, you'll know the weather in California is always super pretty. I've been to San Francisco and it was very, very windy there. So our question asks, what is the range of distances from San Francisco to Oakland? So I don't have to actually figure out how far apart they are, but they use that word range. And another clue is that we really only have 2 numbers in this problem. If I'm checking to see if it makes a triangle, they should give me 3 numbers. But if they give me 2 numbers and they ask me for the range, then I'm going to use this formula right here where I subtract and I add. So if we take a minute and we go ahead and subtract, 51 minus 46 would be 5 miles. And on the other end, 51 plus 46 would be 97 miles. So being careful here, could they be 5 miles apart? No, they could not be 5 miles apart. Could they be 4 miles apart? No, they could not. Could they be 97 miles apart? No, but they could be 96. They could be 7. They could be 50. Could they be 98? No, but they could be anything that falls between 5 and 97. So taking a look at another problem, it says that Ray wants to place the chair so that the chair is 10 feet from the television set. Can the other 2 distances shown be 8 feet and 6 feet? Explain. So the chair and the TV are 10 feet apart. And so it wants to know, can the other 2 distances be 8 and 6? So our question here is, would this make a actual triangle? Could he place everything so that everything is 6, 8, and 10 feet apart? So back up to our formula, I have 3 numbers, so I'm going to use this one right here. So if I add my 2 smaller numbers, that would be 8 and 6. 8 and 6 would be 14. Is 14 greater than 10? Yes. So can Ray do that? Yes, because it makes a triangle. Now, Ray would have had trouble if we had gotten 9 or something like 10, because 9 and 10 aren't greater than 10, so it wouldn't have worked. But Ray is good here. He can place his chair 10 feet away from his TV if he chooses to do so. So taking a look at this next one, it says compare the measure of angle BAC and the measure of angle DAC. Now, inequalities, whenever I'm comparing inequalities, I've got options. One can be less than the other, one can be greater than the other, or they could just actually be equal to each other as well. Okay, so let's see what we do have in this. I see 4 and 4 are the same. I'm going to put a tick there. I see that middle side's the same. I could put ticks there. The only thing that changes from the top triangle to the bottom triangle that we know is that this side is 7 and that side is 6. So let's take a look. If angle BAC, so BAC is that top one, I'm going to do that in green. And then angle DAC in blue, I'm going to make that the bottom one. Really, it's just asking you, how do they compare? So how is the measure of the green one, the measure of angle BAC, how does it compare to the angle of the blue one, the measure of angle DAC? I'm going to give you a minute to look at that green and that blue angle, look at the numbers that we know and take a guess. Do you think that one would be less than? Do you think BAC would be less than, greater than, or equal to angle DAC? Now, if you use these numbers, the green one opens up to a side of 7, whereas the blue one is across from a side that's 6. So 7 is bigger than 6, which means that my green one is greater than my blue one. The measure of angle BAC is greater than the measure of angle DAC, which leads us to something called Hinge Theorem. Now, this is our third triangle inequality, is Hinge Theorem. And there are some different fancy ways that you can say it, but the easiest way to remember Hinge Theorem is that it's big opposite big, or across. So big opposite big. So big opposite big, which would mean that small would be opposite small. So big opposite big, small opposite small, and just remember that opposite means across. So they're going to be across from each other. So just for example, I'm going to sketch out a picture here. Let's say that we have a triangle. Let's say I'm going to make up sides 6, 7, and 8. I'm going to call this angle A, angle B, angle C. Well, in this triangle, 6 is the smallest side, so angle C would be the smallest angle because it's across from the small, so small opposite small. 6 is the smallest number out of the 3, so angle C should be the smallest. Now, 8 is the biggest out of my 3 numbers, so across from 8 is angle B, which makes angle B the biggest or the largest. Remember that big and large mean the same thing here. And short and small mean the same thing. Okay, it works the opposite way as well. So let's just say that we had 3 values in this triangle. Let's say that it was 50, 60, and 70, which 50 and 60 is 110, 70, 180, it works out. So what's the smallest angle? Well, that would be angle 50, so that side across from it should be the smallest side, or the shortest side. Okay, 70 is the biggest, which makes that side opposite 70 the biggest side or the longest side. And then it means that this last side would fall somewhere in between our short and our longest side. That's what Hinge Theorem says. So, taking a look at this triangle, it says name the shortest side in triangle DEG. So looking at this triangle right here, asking ourselves, what's the smallest number? Is it 50, 60, or 70? Well, the smallest number in triangle DEG is 50. So go across. Well, what's across from 50? Side GE. That's our shortest side because it's opposite 50. Now the next one says name the longest side in triangle GEF. So if I look in triangle GEF, longest would be with biggest, largest. So 70 is the biggest number. So if I go across from 70, that would make EF the biggest side in that triangle. And that's how Hinge Theorem works. So sometimes they don't give you a lot of information with Hinge Theorem, and we have to use some prior knowledge that we know. So this one says the variable expressions represent the angle measures of a triangle. List the sides in ascending order. Ascending means small to big. Okay, well, they didn't give me a picture. They didn't give me much of anything. But I do know that all the angles in a triangle add up to a certain number. So think, what do all the angles in a triangle add up to? And if you said 180, you're right. So angle A plus angle B plus angle C should all add up to 180. So I'm going to go ahead and combine like terms. It's written out fairly nice for me. So 6x, 3x, and 5x. 6 and 3 would be 9 plus 5 would make that 14x. 11 and 2 would be 13 minus 1 would make that plus 12 equals 180. And now I'm going to solve for x. So subtract 12 on both sides. So 14x would equal 180 minus 12 is 168. Divide both sides by 14, x is 12. Okay, now I know x, but the problem said list the sides in small to big. Well, if I know information about the angles, I know information about the sides. So if I take a minute and I go and I plug x in, so I'm going to give you a minute. Take x and plug it in here and here and here into the calculator and see what you get. Figure out what's 6 times 12 plus 11. What's 3 times 12 plus 2? What's 5 times 12 minus 1? We're going to see what we get for each one. So angle A should be 83 degrees, angle B should be 38 degrees, and then angle C should be 59 degrees. Well, I see that this is the smallest, so whatever's opposite angle B should be my smallest side. So if I draw a picture of it, if you get stuck, draw a picture. I'm going to label it A, B, and C. So we know that A is 83 degrees, B is 38 degrees, and then C is 59 degrees. So if I'm going in ascending order, small to big, well, we already established that 38 is the smallest number. Go across. What's across from angle B? Side A, C. And then what would come after 38? I'm going from small to big, not A just yet, but after that, I would go to angle C. Okay, so that's the medium number. Go across, and that would be side A, B. And then our biggest number is 83, so then the biggest side would be across from angle A, would be across from 83, which is side BC or CB. And that's how I list my sides in ascending order. Where you need to be careful on problems like this is that a lot of people will go, oh, I did my angles. But Hinge Theorem tells us a little bit more. It tells us small opposite small, big opposite big, so I need to be careful. Okay, taking a look at these next two problems, I see 5k minus 12, 38, and I see 18 and 19. And I'm finding the range of values for k. That's a clue. It's not going to be an equal sign. It's going to be similar to this one that we had up here, where it's probably going to be one of those symbols for me to find k. So if I go back and I look at this, I have 5k minus 12 and 38. And I notice that 5k minus 12 opens up to 18 and 38 opens up to 19. So ask yourself, of those two that we're comparing, which one, how does 5k minus 12 compare to 38? Which one's bigger? Which one's smaller? Well, 5k minus 12 is across from 18, which is smaller than 19. So 5k minus 12 should be less than 38. And we're not going to worry about solving. We're just going to worry about this symbol right here. How did I know that it was less than 38? Because 18 was less than 19. So let's take a look at our next one. I see z plus 23 and I see 3z plus 9. And I'm finding the range of values for z. So I notice that I have one angle is 120. So this angle right here is 120. And that box means 90. So asking yourself, how would z plus 23 compare to 3z plus 9? Well, 120 goes with that and 90 goes with that. So z plus 23 would actually be greater than 3z plus 9. And that's how Hinge Theorem works. Big opposite big and small opposite small. So taking a look at this next problem, it says when the swing ride is at full speed, the chairs are farthest from the base of the swing tower. Maybe you've seen this ride at Six Flags. It spins around, and the faster it goes, the higher up you go. So you start out like flat right there, and then as it spins, you start going out, and then you're almost sometimes like horizontal with that tower. This wants to know, what can you conclude about the angles of the swings at full speed? So this is full speed versus low speed. And what it's asking you essentially is, how does this angle up here compare to that angle over there? So asking yourself, would one of these be bigger than the other one? Well, at full speed, you're farther out than you are at low speed, which means that the full speed angle would be greater than the low speed angle. And it all has to do with this right here. When you're at full speed, you're farther out. And when you're at low speed, you're farther in. So just remember, small should be opposite small, and big should be opposite big for Hinge theorem. So hopefully you learned some things about those 3 triangle